Welcome back, everyone. We're playing the Artisan of Glimmith. This is episode 6. We're playing through. This is a logic puzzle game, and you're trying to complete shapes based on various rules. You can go back to see the prior episodes if you want more detailed explanation of the rules, but it's pretty self-explanatory. We're going to draw shapes into the grid. For this puzzle, each shape has to be an L tetronymo shape. It can be rotated, flipped, mirrored, whatever. It just has to be 3 long and with a 2 long tail. But this is the constraint that putting a lot of pressure on everything. And this is every region we draw has to have a circle in it and a square in it. It has to have one of each exactly. So when we look at it, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 circles. We can count the squares. There's 10 of them as well. So we're gonna have exactly 10 of these L shapes that have to go in there. So when we see an L shape, one of the first things I immediately want to look to is corners, because corners are very pressured. They could either grow like this or like that. But I think what we're gonna see, there is no universe that like those two are not a region. Well, I guess there is. Well, okay, that's bad logic. But the opposite would have been, it would have to be something like it comes down here like this and out like that, or out like this. That doesn't work because that puts 2 circles in there. So we have to be careful on the logic. We don't want to do it. Let's start with something a little easier on the logic scale. Let's draw. These have to be in separate regions. So this grows like that. Here's the question. Is it an L? The answer is no. It can't grow that way and it can't grow that way without hitting the thing. So it has to go up, and so the short end can't go that direction. It has to go that direction. So forget everything I said about starting the corners. Start where they have a bunch of shapes piled in together. That makes a lot more sense. All right, let's see where else we can. Our eyes are scanning, looking around. This little corner here is blocked in with 2 circles. So it's going to be either with this circle or that circle. I don't know which one. Same thing with this. It's going to either go with that. It's not going to be one of those types of shapes. That's it's not going to be that either, right? So it's either an L like that, an L. It's not L like this. That doesn't work. It could be like that, but not really, because that puts a pressure down here. So that doesn't really work. It could do something like that. But again, now we're getting more into like just trying to try different shapes. That's not really how these puzzles are meant to be solved. But I'm playing around with it just to have a little bit of idea, see where the pressure is. And it seems like this square, it needs to be connected to a circle and a square. And so it's going to have to connect to one of these circles and one of these squares. But that could be that direction, or it could be that direction. Or it could be that direction, or it could be that direction. Now this doesn't work. So I mean, I guess I could. It's difficult to. Okay, let's go here. This square. Let's try this one. I'm either going this way. That's option 1. I can't do this. That option's out. Or this. So I really have 2 options here. Do either of these options limit my choices for the future? And I think I have a problem with this one. Now, the reason I'm not considering, I mean, I have to, from this one, I have to get to a blue rectangle, or square. I have to go from here. I have to collect this one or this one. There's no way that I have to be connected. So, but I think this is a problem. And I think the problem is right here. What comes out of this? Like, where does this go? And you say, oh, I can go here. Well, that creates a dead spot. That doesn't work. And this doesn't work going the other direction. That's a dead, like it creates a dead spot no matter what. So this is not an option. This is the way it has to go. It has to go that direction. This can't grow like that. That creates a dead space. It can't grow like that because it still has 2. So this has to grow like this. And now this has to grow. This has to be at least 2. This has to be at least 2, and that's forced. That's forced. That's forced. All right, so these 2 cannot be in the same, so I can't go up that way. So I have to go up this way. Now this one, I have to grow. I can't go that direction, so it's going to go like that. This can grow like that, and we're done. Okay. I didn't feel like that was the cleanest of solves there, but it was correct. And by clean, I mean I want the solution to be based purely on logic. I do not want to be guessing my way, trying different patterns, and I want to go through base logic, core, first principles. Work through the solution. All right, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8 regions. 8 regions. And there are, it looks like 4 shapes. Is that right? So 4, yeah. 8 regions, 4 shapes. Which shape gives us the most pressure? I'm looking for pressure points. Looking for pressure points on the puzzle. So seeing these 2 reds close together, these greens, like the greens with the yellows here, there's a lot of pressure right there. Like whichever green here, it's going to take a yellow, which then immediately knocks it off, and then this one have to take a yellow. Or this one takes yellow, or like this one takes yellow and that one takes yellow. Now they could both go out this direction like that and snake their way around. But I'm not looking to just try different, but I do see there's pressure here. There's a lot of, it's very difficult. It's very difficult for, like once one of these takes, the other one's being almost forced. Let's see. So kind of another situation here with the blues. We got all right, the blues are interesting because there's 4 blues congregated over here, and we got 4 blues congregated over here. So one thing to consider is that each region is going to be exactly 4 long. So when I look at, if I compare distances, so like if I take this green one and I look at which blues are even available to make part of this, I can say, well, this is within 4. This is not. I cannot use that. This blue cannot be in the same region as this green. It's too far away. You know, if I did straight line, that's 5. And we know that each region's exactly 4. We don't know the shapes. We know it's exactly 4. But it could be this one. It could be that one. But it's very, if it's this one, like that is the region, right? Now that's a problem. This is a problem right here. Because then this region, how does it get out? It's stuck. It's trapped. So I can say definitively that these 2 don't go together. This diamond does not go with this square. So this diamond The only square that works with it is here, and it's going to have to take this along the way. Now, I don't know if it picks up this circle or that circle. I do know that it doesn't go that way. I do know it doesn't go that way, but I think that's a good. I think that's a good logic, a strong logic opening there. Is there anything else that's pressured with blue? Because blues are. All right, this triangle has two blues it could connect to. Here and here. I'm going to do a similar kind of logic. If this triangle connected to this square, what happens is that this is broken. Like this can't get anywhere. This can't happen. So this triangle must connect to this square. These squares are too far away. All the others are too far away. So these two are together. I don't really have a way to do that. We're just to remember these two go together, which means these do not. That's what we're getting out of it. We're getting that these triangles do not go with this blue because that triangle does. Let's look at this triangle. Which blue goes with it? It's either this or this. Either way, that takes 4 squares. That's a problem, isn't it? Not necessarily, but what it means, that's either going up this way or up's going up this way, or going like this. Either way, it's taking up 4 squares, and that's the only place it can get a blue because this blue's taken. So this triangle needs one of these blues. It takes 4 squares to get there. So I can draw a line here. This triangle does not go down. So this has to go over. This now, diamond already done. So this comes up. Now we know that region. This comes up. This one needs its last circle. That comes up. And I don't know if we go up and over, or up and up. We'll have to work that out, but we're getting somewhere. This is a new region. It comes up and over. I don't know if it takes this blue or this blue. Let's say it took this blue, just for hypothetical. That creates a problem. How does this escape? It can't. So this does need to take that. All right. Yeah, this is coming along okay. Where does this triangle get a circle? And the answer is here. It can't get there. It can't get there. These are all taken. So this and this are together, which means this does not connect because this triangle needs to go somewhere else. But it does ask the question, where does this triangle get a circle? And that answer is here. And since it can't go that way, this is force. We just get a region right in the dead middle of the board. And I think that's going to force this to go around that way. But I'm not going to look at that just yet because I think this just got forced. And I think this just got forced. And then this comes out. This comes out. This comes out. This comes down. This comes out. This comes out. Yeah. All forced. Okay. Ooh. Ooh. All right. So we have. How do we create a region like that? How do I create regions that have spaces in the middle like that? Like, how do I link regions together? Oh, no. I'm sorry. There's 2 different... These are 2 different things. It's either a 1x1 or a 1x4. Okay. Laugh, make fun of me in the comments, folks. Oh, like, it's got to be a shape like this. No, it's a 1x1. So this is a valid region. Now, here's the question. Why can't we just do this? And the answer is because then there's not a circle in there. All right. Each region must have a shape in it. Let's go and break things up. Let's work this logically. But I just want to ask that question. Why can't I just do that? The answer is that's not a valid region. It doesn't have a circle in it. But what we can say, those are all separate regions. Now, this is an interesting point. This line right here, this cannot be a 4. It can't be a 4 up, can't be a 4 over. So this is a solid region. Now, this one, that's not true. It could go this way. It could go this way. This one cannot go up, cannot down. So this is a finished region. This could go up. That can't go in. That's locked off. This could go this way. So here's what we can say. This cannot go up. This region can't go up. This region can't go up. So where does this go? This is going to go like that. This is how we do this one. All right. So I think this is going to have to connect here. Yeah, what goes here? This has to come out. It goes there. This is a 1x1. So this right here, this cannot be this region. It cannot be that region. It either connects with the purple or it connects with the blue. One or the other. So I don't know which one, but it connects to one of them. But so I'm going to do is I'm going to draw this here. Draw this here. I just don't know if the line's here or the line's here. But that raises the question, where does this one go? And the answer is it goes there. There we go. Okay. Because this could go down, this could go down. Let's see. What about this cell right here? Which region is it attached to? Not the green. Not the purple, whatever it is. It's going to connect to this blue. And let's do that the other way around because I like the blue. Oh, I changed my... Oh, there we go. That's the better blue. So that is definitely not the case there. Okay, what about this purple? It definitely doesn't go up. So that's the question, where about this? Where is this one getting its? And the answer is it gets it from here. So that has to go like that. Where does this cell get its region from? It has to be there. Now this region can no longer grow this direction. So that is off limit. So where does this one get the region? From here. That doesn't grow. Where does this one get a region from? It has to grow from here. That doesn't. Where does this one get its region from? There. And where does this go? Just like that. Okay, we got two shapes here. It's not a crazy shape, folks. Don't. I heard you. I heard you laughing at me. It's either a U or a J. That's what I'm calling them. And then some rotation, symmetry / mirroring. And then we've got the rose windows. We have to connect the reds and the blues together. So we're not going to just go around willy-nilly just trying stuff out. That's not the way we do this. We're going to approach this from first principles. And I think what we can say is that anytime we have a hole, that hole is going to be one of these circles. So the U's, no matter how you do it, whether you're doing it like this or like this, it's going around those center parts, which means 3 of the 4 sides are the same shape. So what that tells me is the U or the J, this is not a valid operation. These two cannot connect. So by process of elimination, these two do connect. And it has to go this way because otherwise it creates a dead end. So now I don't know if it's a U or if it's a J, but we can say with certainty that is a correct shape. Now, I believe we can actually take that a step further. I think the U's, could you ever have it not be the 3 on the edge? Could it ever be something like this? And unless maybe it's a better, let me do it with we'll try it like this. So it's where it's a valid region. So it doesn't violate the rose windows. But could you ever have something like this? The answer is no, because there's no shape that can fit in here. So we are stuck with that. All of these have to be in this kind of configuration. Now, what we are stuck with is, how do we get these last few done? Now, we could do some mathematics on this. I don't know if you're supposed to do this or not, but this is a 5-cell shape. This is a 6-cell shape. And we have a grand total of 1, 2, 3, 4, 5, 6, 7, 8 cells remaining. 5 of them are guaranteed. So we'll put a U in here. It's going to take up 5, which means exactly 3 of these shapes must be a J. 3 of them, because we put a 5 in there, we have 3 cells left over. So where is the J going to be? So I guess the question is, the last U, is it go in this rotation? Does it go in this rotation? Does it go in this rotation? Or does it go in that rotation? Those are our 4 possible rotations for the and I think we can eliminate some of these rotations, because we cannot, like, let's just look at this one right here. This, well, it violates this up here, but this cell right here is in no man's land. It can't connect to anything. So that's off the table. We could flip it around and we have the exact same problem up here. This is a valid shape, but this cell here, it's in no man's land. So both of these are not valid, which means it has to either be this direction or this direction. And as you saw, we can't go this way because that puts 2 in here. So this is the correct direction. This is the U. This still needs a square. We grab that there. This still needs a square. We grab that there, and then that finishes it off. So there's the solution. All right, so we either have to be a 1x3 or a 2x2. So let's start with this guy right here. Could this be a 1x3? Not that direction, and not in that direction. So this is a 2x2. What about this guy? Can he be a 1x3 in this direction? Nope. In this direction? Yes. Could he be a 2x2? No. So by process of elimination, that is his choice. Let's look up here. This guy cannot be a 2x2. He can't be a 1x3. So we'll make him a 3x1. This guy has to be a 1x3 just by thing. That has to be a 1x3. This cannot be a 2x2. Cannot be a 1x3. It has to go down. This square could be a 1x3. This could be a 1x3. It could be a square. It could be all 3. Nothing. We can't deduce anything from that. Why did I? Oh yeah, this couldn't be a square. It could be a 1x3. Okay. This could be a 1x3. Could be a square. Both options are valid. This could be a 1x3 down here somewhere. It could be a square here. So I could do 1x3s, 1x3s, 1x3. That doesn't work. Okay, so let's do some mathematics again here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 remaining. So the reason I'm doing the mathematics is one of these shapes is an odd number of cells, and the other one's an even number of cells. 17, we have to get some combination that's it's 3x plus 4y, and x plus y has to equal 1, 2, 3, 4, 5, right? So we could set up the linear equation and solve all that. I'll leave that for the exercise to the viewer. We're just going to kind of force the math a little bit. But does that make sense? What I was just saying here? Let me break it down. If you don't have a math background, let me simplify this a little bit. I have to have some number of 3-cell shapes and another number of 4-cell shapes. I know that it's not all 3-cell. I know it's not all 4-cell. The reason I know that is I have a grand total of 17. 17 is not a multiple of 3. It's not a multiple of 4. So I need some combination of 3s, some combination of 4, and grand total, I need 1, 2, 3, 4, 5 shapes. So I know I need an odd number of odd cell shapes. So I'm just going to say I need 3. I need 3 of these. So that's 3 times 3 is 9. I need 2 of these. That's 2 times 4 is 8. 9 plus 8 is 17. That's the solution to it. So I need to be able to fit into this space, to have exactly 5 shapes that take up 17 slots. I need 3 1x3s and 2 squares. So let's start with the squares. Where can the squares go? Can the square go? Can this be part of a square? No. So this is a 1x3. It's either this way or this way. Could this be part of a square? No. This is part of a 1x3. Either this way or that way. Could this be part of a square? Maybe if it was right here, but that creates a problem up here. Yeah, so this is not a square. This is a 1x3. So here's our 3 1x3s right here. This one, and this one. I think that's. Oh no, we have 4. We have 3 3x3s and 4 2x2s. Okay, so let's not say that. That could. But this is definitely a 1x3 somehow. And this is a 1x3. Because it can't be a square. It seems like this has to be a square, right? Because I already have 2 of my 1x3s. And if I put one of them here, I'd have to put the other in here. So this is a square. This now can no longer be a part of a square. So it's a different, and it's not the 1x3 of this one. So this is a 1x3. This is a 1x3. I need a square and I need a 1x3. I'd be interested if people approach that problem a little bit differently. Again, I don't want to force the solution. I'm trying to come up with logical approaches. I mean, the solution I came up with was maybe, I don't think I was supposed to use that kind of logic for a difficulty 3. I think there's probably a more straightforward logical path there that just said you had to put a square here, you had to put a square here. But to know that you had to have 2 squares, I don't know. I don't know if that's over an analysis, but you guys can let me know. Anyways, that does finish up the rows windows section. So we could continue on over this direction, which I don't know what this is. This a scroll here? Esteemed artisan, I apologize for the preponderance of constraints I've laid upon your work. Many further rules are yet to come. This area is optional. You may proceed as soon as 4 windows are complete. So we do have the ability, because we've done 1, 2, 3. No, we've only done 3 windows, so we can't go that way. We're back to starting this space here. And I think I wrapped this episode up. I'm a little early here. I'll bring up the puzzle here. We have a new puzzle rule. I'm not going to solve this puzzle, but I'm just going to look at this rule set. We'll delve into it in the next episode. But a delta is the 2 regions touching this symbol must be different shapes. Okay, so I think we can figure that one out. Anyways, we're going to come back to that. We're going to start this next section here and delve into it. We just finished up the rows section. Got the gold there. Yeah, so that's done. Oh, wait. There's puzzles over here we did not complete. What's going on here? What's going on here? Wait a second. Wait a second. They're very challenging, careful, advanced techniques. Breaking steps may be difficult to spot. Got it. Ooh. Well, folks, we are out of time, but maybe do we start with one of these puzzles next time? I don't know. Sounds fun. Lots of good stuff coming up ahead. Catch you in the next one. Bye, everyone.